Ladies and gentlemen, welcome in this afternoon session. Your presenter for today is Arend-Jan.
Oh, look at those spotlights. Hello, everybody. So, you all had lunch and now looking for some sleep? I guess so. I mean, after lunch, everybody's going to fall asleep. That's what always happens. So I'm not going to blame the topic. I just will blame the lunch. So hello, my name is Arend-Jan Kauffmann from the Netherlands, freelance technical consultant and also trainer. Always been on the technical side for more than 20 years in Dynamics Nav, Business Central, and special focus on web services, APIs, security, etc. And in the Netherlands, I also try to keep up with the Dutch Dynamics community. All right, so why do we need to talk about OAuth? Well, Microsoft helped me this morning in the keynote because there was this slide. This is what I took from the screen, so I added it after the keynote. They're moving to OAuth very soon, 1st of October. So that is in 2 weeks from now. So if you have not moved to OAuth, you better move fast. There's a lot of work. Or maybe not. Maybe hopefully after this session you have an idea how to do that. Now one of the reasons Microsoft gave here, or the reason, is security. Security, security. Yep. You see what is on that picture beneath? For those who have already worked with OAuth, they probably recognize that. Well, so they recognize here an access token. You know what this is? I'm going to click on it so you can read it for yourself. Microsoft Teams stores the tokens as clear text in Windows. How about security, Microsoft? I mean, this can be simply leaked with a simple attack, and then attacker has full access. So, what can we learn from this? OAuth is not secure in itself. OAuth is as secure as you understand and apply it. If you don't understand and apply it in the correct way, it will still be unsecure. And even Microsoft is sometimes getting it wrong. Okay, so I proved my point, and now I have to get it right myself, of course. So, you know this meme? How to draw an oil? People give you 2 circles, and they say, okay, now you draw the rest of that oil. Yeah? To translate that to OAuth, they say, okay, we're going to do OAuth. You create an app registration, you have a secret, and you get an access token. Well, that's it. And all the steps in between to get from those 2 circles to that oil, to get from an app registration to an access token, you have to figure out yourself. To read here, read there, read a blog post, and, well, that cannot be that simple. Because there are a lot of terms going on. And I hope to, well, catch most of those words that are on this slide. So, OAuth, what is it? OAuth, this is the definition of OAuth. I don't understand it actually. Definitions, not for me. But okay, this is the official definition, and this is not managed by Microsoft. It's managed by an external group of companies. It is an authorization framework to enable, and that is what it is about, a third-party application to get limited access to an HTTP service. In terms of Business Central, to get an external application to get him access to Business Central data over an API call, a request. But it could also be the other way around. From AL code, get access to something outside Business Central, like SharePoint, email, OneDrive, you name it. So it is an authorization framework, and it has many phases. In OAuth, we have 4 different roles that are important. And I will build the story on these 4 roles. We start with the resource server. In this case, we put the name Business Central on it. Resource here means something that has data. So the Business Central server is the resource server exposing data to the outside world by means of HTTP APIs. Then we have a client application, not being the web client, that is an application of Business Central itself that has access. No, an external application created by a third party. And that client application now wants to get access to those resources because there is a user who is an owner of the resources. So that is a Business Central user who wants that application to read data or maybe send data from Business Central. So he's going to use an external application, not a web client. And Business Central knows that user, of course, but it doesn't know that application. And that is where Azure Active Directory comes in. That's the authorization server. Business Central does have a registration in Azure Active Directory created by Microsoft. We will see more about that in a minute. Now, that client application also needs to get a registration in Azure Active Directory. And then the client application can request to that resource owner, please give me access to your resource. And Azure Active Directory can store the granted permission from the user to that client application. And if that client application can prove to Azure Active Directory that it is really the resource owner that is trying to get access, the resource owner can prove that by logging in. And if the client application can prove that he is really the client application that he says he is, then Azure Active Directory gives him an access token. And that access token is then sent to Business Central together with a request, with an HTTP request, and Business Central can check that token and then revoke access or give access. So that app registration, that is an important part. It starts there. It starts in the Azure portal, Azure Active Directory, and there we have an option in the left menu, app registrations. Of course, you're going to see that in a demo later. In that app registration, we have the definition of the application. The definition. So that includes the name, maybe a logo, the publisher, so the company who is publishing it. It contains redirect URIs, it contains secrets, it contains API dependencies. Which resource is he going to need? Without a required resource, he has no access. So you can store there which application do he wants to access. It can have published APIs. The application on itself could also expose resources, which is, for example, the case with the Business Central app registration. It exposes data. Now, that app registration only exists in a single directory, an Azure Active Directory. That is called its home directory. Then we have another thing in Azure Active Directory, and that is the service principal. In the menu in Azure Portal, that one is called Enterprise Applications. don't ask me why they give it a different name in the menu, but sometimes they do. As we will see later in other places, that is happening as well. Anyway, the enterprise application or service principal, and I prefer to use the word service principal, that is an instance of the app registration. So think of it in terms of AL code. We have a code unit written in an AL file, but that doesn't mean that that code unit is loaded into memory. It is loaded into memory when we have a variable of type code unit for that code unit. That is the instance of the code unit. And we can have many instances of one code unit, as many as we have variables pointing to that code unit. So the same happens with a service principal. It is an instance of the application registration, the app registration. And on that instance, we have the granted permissions. Now, this is an important difference from the required permissions. In the app registration, we can configure which permissions, which access does it need. In the service principal, we store which access has been granted. And based on the granted permissions, he can get an access token. And that service principal can only grant access to something that is in the very same Azure Active Directory. It cannot grant access to something that is outside the Azure Active Directory. Let's see that in a picture. There's going to be a lot of pictures here. So we have an Azure Active Directory, the blue box. And inside there we have an Azure App Registration in the top. And that one is also a link to a service principal. That's its instance. That's how it starts. The moment that you create an app registration in your home directory, you also get that service principal. Now, the next thing, okay, I was hoping, okay, sorry, this is what we call a single tenant. So a single tenant, everything is inside the single tenant. We also have something that is called multi-tenant. When we have an app registration that is multi-tenant, then the app registration stays in the home directory. But the service principal can be created in other Azure Active Directories. And in the other Active Directories, it can be granted permissions to resources inside the other Azure Active Directory. Now, when we create an app registration, this is one of the choices that we need to make. Is it going to be a single tenant or a multi-tenant? And the answer to that depends on which users are going to use that app. Are they only inside this home directory, then you have a single tenant application. But if users here also needs to make use of this app, this client application, then you can create a multi-tenant app, and then a service principal can be created in this Azure Active Directory. How that happens, I'll talk about that, of course. So what do we use that app registration for? What is the purpose of an app registration? Actually, we have three possibilities here. First of all, we can use it for user authentication. Just getting access to the details of a user. Reads its details, who is he, what is his email address, whatever is stored in Azure Active Directory. Another access that we can have is saying, I want to have access to other resources. Data that is exposed by other applications. Think Business Central. But it could also be SharePoint, could be email. That access that he requires needs to be granted. Just saying that you need the access is not enough. Then, on the other side, it could also expose resources. It could be a server that as a server application is data behind it that wants to expose the data with an API. And then it can also register the API endpoint, the name of it, and say, okay, another application can get access to my API endpoint. Under this and this name and with this and this permissions and roles, there's another part of app registration. That's actually what Microsoft is doing with the Business Central app registration. They created an API exposing, so it's exposing an API and saying, okay, we have an impersonation scope here, and we have an API.readWrite.all role there. We will talk about it in more detail, but that is what's happening with the Business Central application. So, when the application wants to access a resource, he needs to get permissions to the other resource. In fact, that is the other resource is just another service principal in the Azure Active Directory. And then between the service principals, there is a granted permission. Now the question is, where does that other service principal come from? Well, from another app registration. And if it is single tenant, that's obviously, then the other app registration is also in the same tenant. Then, for example, we could have a client application, let's say it could be a PowerShell script, it could be a console app, it could be whatever, an application that wants to get access to an internally developed application, for example, a portal where somebody can enter time registration or other. On the service principal level, the permission is granted. Now, if we put that with some bullets here, and that's too fast. If you put some bullets here, in the top we have the required permissions, so that is only on the app registration. Doesn't mean that the permission has been granted, but the granted permission, that is between the two service principals. This is the single tenant part. Now what about the multi-tenant part? Then we can have a multi-tenant app registration, let's say in another Azure Active Directory. That app registration is multi-tenant, and that app registration can have a service principal in your home directory, and you can grant permissions. To put some names on that, Business Central is registered in the Azure Active Directory managed by Microsoft, and it is a multi-tenant application exposing APIs, and the app registration in your home directory says, I want to get access to that exposed API. And then the permissions, if they are granted, are registered on the service principal, and that service principal here, this one, represents the application of Microsoft that is registered in their Active Directory. To make this a little bit more complicated, we can also have this scenario. What do we have here? We have an Azure Active Directory where we have an app registration. It has a service principal, but also here a service principal. And let's say this directory is a directory from an ISV or a partner, creating an app, and that app needs access to the Business Central resource of the customer. So the middle one here is the customer. This app registration is not done here, it's done in the ISV app, the ISV home directory. But the moment that somebody here grants access to this app registration to this app registration, we have a granted permission on service principal level. So we have a service principal from Business Central and a service principal from that web shop. So let's make that picture a little bit more clear. It's this. Because we're not talking about an application that we're using ourselves. We're talking about an application that is sitting in the home directory or the Microsoft directory with a service principal in the customer directory. But hey, this piece, where does that come from? Because that service principal is created in the home directory the moment that the app registration is created. You get that service principal there automatically. But how do we get that service principal in that customer directory? How does that service principal from Business Central come there? And how is our web shop service principal being created there? And that is actually the question. So, how are these service principals created? In the home directory, they are created the moment that the application is created, that app registration is done. If you use the Azure portal, app registration. If you would not use that, but you go with the Graph API, there's also a possibility, then you need to do it yourself. Then you do a Graph API call to create the app registration and a second one to create the service principal. So in fact, Azure portal is doing 2 calls and not only 1. In the foreign directory, let's say that customer directory, it can only create a service principal if the app registration is multi-tenant. Otherwise, it stays inside the home directory and does never leave it. And it is created the first time when permissions are granted. That app registration starts with requesting permissions, requesting consent from the user. Do you allow me to get access to your data? And the first time, it starts with Business Central. Business Central is asking the user, do you allow me to read your data? Otherwise, he cannot authenticate him. So the moment that the user says to Business Central app, yes, you may read my details, the service principal for Business Central is created in the customer directory. That service principal comes from an app registration that also says, hey, I have APIs exposed. Then the web shop example comes next and says, hey, you have that resource, please give me access. And at that moment, that the user says, yes, you get access to it, the service principal for that web shop application, which could again be anything, is the service principal is then created, and together with it, permissions are granted to the service principal of Business Central. Okay, permissions. So permissions are granted, and what is all of that? What does that exactly mean? Permissions are, well, something that an application requires. An application requires access to a specific resource. There you have the term resource again. A resource is just another app registration that is exposing data. Exposing data usually done with a REST endpoint. It could maybe something else, but usually it is an HTTP REST endpoint. Access to that endpoint, to that exposed data, is managed by scopes and roles. That is something that is done on the app registration. The person who manages that can set different access levels. If another user is allowed to access the data with a third-party application on behalf of that user, then we call that a scope. That's the official term for it. We also have roles, and roles is something that is widely used in Azure Active Directory, or in the Azure portal actually, for access management. Somebody can have a role and then get access to certain parts. Well, there are two types of roles that play a role. You have the user role, which can be assigned to a user or a group of users, and we have an application role, which is a specific role type because you do not assign it to a user. Now you see the user role line is gray, and that's for a reason, because that does not play a role here. The user role is in fact not used because we have scopes for that. With a scope, it is possible for an application to access Business Central on behalf of the user. With an application role, there is no user behind that application, but instead, he accesses the data with his own application account, his app registration account, in fact. Well, you may think, okay, this is a little bit confusing and I don't get the picture here. You will get it later, hopefully, when I going to do the demo and point you out in the demo what exactly is related to these slides. To give you some examples of scopes and roles, and hopefully you already recognize here something. A scope could be API Business Central.dynamics.com/user impersonation. That is a scope defined by the Business Central app registration in the Microsoft directory. Another scope could be graph.microsoft.com mail.read. Well, what in fact, this is built up as a URL, as you see here. In fact, it's a URI. And up to here, this identifies one app registration. And the second part is, in fact, the permission. Together, we call it a scope. This is one-time app registration that is done, and this can be multiple types. In the graph, we have not only mail read, but we also have mail read write and mail.send, file.read, file.read write. There's a huge list of scopes. You also see an application role here, api.readwrite.all on that same resource here. So this resource and this resource are exactly the same, but this one here is API readwrite.all, which is an application role. It's just because that has been registered under a different page, on a different property in Azure portal. We also have mail.read, and that looks the same as scope. Well, that is because in the graph environment, I have chosen to give the application role the same name as the scope. So we have the same name, but it could be two different types. Like, can be a little bit confusing. Business Central chose to have user impersonation and API read-write.all as two different names. It could have been API read-write-all on the scope as well. But user impersonation is actually what it is about. Well, you see the two pictures, a little bit blurry, but I hope you can see and read that here, request API permissions. This is inside the Azure portal, and here it says delegated permissions, and over here it says application permissions. Delegated permissions is in fact another word for scopes. I cannot help it. Here we have another example where behind the scenes it's called a scope, but in the Azure portal UI it's called delegated. Sorry about that. You also see on the right screenshot, and trust me, we're gonna be there later on in the demo. But you see here, type, an application, and delegated. It's exactly the same thing. Now, the moment that the application requests to the user, grant me those permissions. I've not only told you which permissions I require, but now I want you to grant me those permissions. That is called the consent flow. And you probably are familiar with this picture, the pop-up that is asking consent to the user. Now, there are many consent flows. We have a user consent flow, which is the process where a user is granting authorization to an application only for his user account, so on his behalf. That's what we call a user consent flow. We also have an admin consent flow, and that happens when an admin is granting consent, because an admin can grant permissions on behalf of the whole organization. So the individual users do not get this question anymore. That's what we call an admin consent. And it is a different page that the user can be sent to. Please log in as an admin and grant as an admin for the whole organization. And that is the difference between, or the different flavors of the consent flow. If there is a user consent flow, so asking a user for permission for his resources, but if that user is an admin, then there will be this little box here, consent on behalf of your organization. Optionally, if he doesn't tick it, he's only granting for his personal user account. But if he ticks the box, then he's suddenly in the admin consent, granting permissions for everybody. I hope you see how many different flavors we can have here. Then we have the application role type, where it is not a delegated permission, is not linked to a user, but the application role, then an application is using his own account to get access. That can only be done by an admin, not a user. Think of that as creating a new user account in Azure Active Directory. Users cannot do that. Only an admin can create new user accounts. An application role is in fact another user type application, a new service principal and not a user principal, something that also exists in Azure. So he's creating a new application user, in fact, and that is only be possible with an admin user. Well, you see that a link, and actually I found that one when I was looking for this, and yeah, I didn't want to go there now. This one is actually a very good overview of all the different flows, completely explain what every part of that page means. And not only that one, but this is the next one, and the next one, and the next one, and another one. Well, all kind of different situations that can happen during the requesting authorization. So actually a very good resource to read. Now, so far I have been talking about server principles, permissions. There are some other parts in the app registration that also play a role that I didn't touch yet. We're talking about the difference between a public app versus a confidential app, which is related to something that is called redirect URI. Something that I believe most people are struggling with that one. What exactly is a redirect URI and what does it do? I've not talked about secrets. Well, that's a secret, so let's keep it a secret. Now, I need to talk about secrets, of course. I've not talked about dynamic permissions versus static permissions. And, of course, the access token itself. Because whatever we do, at the end, we need an access token. And that is actually what I want to talk about now. And then later on, I come back to the redirect URI and public and confidential clients. The access token is used to prove that an external application, in fact, has the permissions. It contains all required information. Who is the user? In which Azure tenant ID is he? What kind of access does he have? Is this a user or maybe an application? What role does he have? When did he acquire that token? When is the token expiring? All of that information is inside that token. You see here a call, how that looks like, API Business Center networks.com/v2, we know that endpoint hopefully, /production, or could be /sandbox, /development, whatever name you have for your environments, and then /API. Okay. What you do not see in this URL is the tenant ID, the Azure tenant ID. That is not required because the Azure tenant ID is in fact in the access token. So this long string here contains that information, so we don't have to put it in the URL anymore. Well, what is that token? It is a so-called JSON web token, which is a base 64 encoded value. Well, in fact, a URL encoded value. A URL encoded value means that it does not contain slashes. Were replaced with, I think, a dash, top of my head. It does not contain, there are two characters actually removed, and the equals sign is removed from it. But you can replace them back. This is just encoded so that it can travel over a URL. It is base 64 encoded, which means that you can just decode it to read it. It is not a secret what is inside the JSON web token. You can just decode it. You can even write code in Business Central, I've done that, to decode a JSON web token. It's just a matter of splitting it up because it consists of 3 parts divided with a dot. Then you take the middle part out of it, and in the middle part, that looks like this. It's a JSON structure. You can do this yourself also at jwt.io or .ms. I usually go with the first one because that gives me a little more information. But okay, if that JSON web token is that simple, then everybody can create it, right? Well, yes, you can create it, of course. But the JSON web token is a secure token because it is signed. Signed with a private key from a certificate. And that means that some application that receives the JSON web token can check and verify if that token is valid and really created by the owner of that private key. It's in fact done with hashing information and encrypting the information. And that is in the bottom of the JSON web token as a signature. And that signature can then be decrypted with the public key that belongs to that private key. And then you can check the hash. If the hash does not match, then it is not a valid token. You can even do that in AL. I've done that last week, actually, creating JSON web tokens with a certificate in AL code and sign it, and it works like a charm, actually. If I have time at the end, I can show you the code. Business Central uses this JSON Web Token to identify the user and to see, hey, what does he have for permissions? And inside that token, we have, for example, the let me see, organization ID. We have a scope. You see here, hopefully you can read it, user impersonation, the name of the user. We have the audience, API Business Center, dynamics.com. So for which application is that JSON Web Token meant? All of that is inside that JSON. Okay, so the question is, how do we get that access token? Well, there's a list of flows here. And with flow, we mean a series of steps that you can follow in order to get a token. And every flow has a different purpose. And I cannot discuss all the flows here. I have to make some choices. So the only two flows that I want to talk about is the authorization code grant flow and the client credentials flow. Because the others are for specific situations. There's one flow that many of you have also experienced from the others. I guess you all have seen that if you publish an app in VS Code to a Business Central online sandbox, you get that little pop-up that says, here is a code, please click on the link and paste the code in the website. And then the website says, okay, are you this and this user trying to log in, etc. And in the meantime, VS Code is waiting for you to finish that process. And when you have finished, he will continue publishing the app to Business Central. That is the device code flow. A specific flow for applications that do not have access to a browser or do not have their own browser window. Especially, and that's why it's called device code flow, for TV screens. Okay, but I want to focus on the authorization code grant flow and the client credentials flow. Because the first one, authorization code grant flow, is used to get delegated access on behalf of a user. That is where the word authorization code comes from. He's asking the user to give him access to Business Central, for example. And if he has the access, then Azure is going to give an authorization code. And with that authorization code, he can get an access token. And that is actually the flow that most people are struggling with. Because a redirect URI is involved here, a secret is involved, you have user interaction. That can be really confusing how all of that works. The client credentials flow, on the other hand, is the easiest one. Just one call and you have access, and you have an access token. So should we all go with client credentials flow then, because the other one is so difficult? No, because the authorization code grant flow is to access data on behalf of the user, and the client credentials flow is to get access on behalf of an application account. And you don't know who the user is. So the authorization code grant flow is used in a user interactive session. You're going to access the data on behalf of the user, and that requires that a user is logged in. So the first step in that process would be to let the user log in if he is not already logged in and recognized by the browser. Of course, you can say, but wait a second, I don't want him to automatically be recognized, and you can add an extra parameter, say always prompt to log in. You're going to access the resource on behalf of that user. That is when we use the authorization code grant flow. That means that the permission type that we are talking about is of type scope, aka delegated. That is what is named in the Azure portal. That also means that in the target application, Business Central for example, there must be a user account for the same user that is logging in into the application. The client credentials flow is also known as the service-to-service authentication. You don't see that in the docs from Microsoft, but that is the authentication type that Microsoft likes to talk about, well, at least from Business Central perspective. Mostly used by a background session where there is no signed-in user. Think an Azure function or a web shop application where the users of the web shop are not users in Business Central, but are the customers of the customer. So they cannot log in into Business Central. They cannot give access. But the web shop needs to get access to Business Central in order to get inventory information, create sales orders, shipping information, stuff like that. The permission type in that case is then application role and not scope or delegated. But that also means that there must be an account in Business Central, and we call that an application account. It's just another record in the user table that is not linked to a normal regular user, but is linked to an application, an app registration. Type, user type, application. Well, how does that authorization code grant flow work? If you look it up in the docs, you're going to see this schema, this flow. Yeah, I don't know about you, but if I see this kind of pictures, in most cases I just skip it. It's way too complex. Unfortunately, I have to come back to this picture because everything that I need is in here. So let me try to explain it a little bit. In the top here, you see two blue boxes, authorize and token. That are two different endpoints on the Azure API. The Azure API, which starts with login.microsoftonline.com. And then it is even /tenant or /common, well, /organization should be used, but that's on the next slide. But two endpoints. The first endpoint, authorize, is something that is opened in a browser. It displays a web page. A web page that asks the user to log in, asks the user for permission if he grants that application permission, which is, by the way, a one-time question. The next time he would not ask that again. So the second and other times that he logs in, he will just skip the grant permission question. And that is what happens here. The application opens a browser dialog pointing the user, sending the user to the authorized endpoint. With some parameters, I am this application requesting access to this resource with this scope. The user follows the flow in that web page to log in, maybe give permissions the first time, and then that authorized endpoint is going to send the user back to the application where he came from. That is the redirect. Sending the user back to the application, because Azure does have something for that application, an authorization code, telling the application, hey, this code tells you that you have got permissions from the user to get access to his resources. Now, that application needs to grab that code out of that redirect page that is opened in the browser, is the final place where the user goes to. And then he goes with that authorization code to the token endpoint, and he gives some details to the token endpoint. Hey, this is the code that I got from the first step. This is my application ID. This is my secret. please give me an access token. And if everything is verified and okay by the token endpoint, then the token endpoint replies with an access token. So this first part, the authorize, is a user interactive browser. This is just showing a web page series in the browser. The second one is an API call behind the scenes. The user doesn't see it. So there's just an API call to the REST endpoint of with the token endpoint of the Azure API. And then when you have the access token, you can use it together to call Business Central. Explained in more detail. Here you see the full call for the first step to the authorized endpoint. This is a URL that needs to be created by the application, and there must be a browser dialog opened somehow so that the user is opening that login page. You see here, inside that URL, login.microsoftonline.com, you see the domain name. In this case, kronos.company. That's the domain name that I put in there. By the way, that one really exists, kronos.company, as a domain. You see at the end, authorize here. If it is a multi-tenant application, then you do not know which user is going to log in. It could be a user in your Active Directory, it could be a user in another Active Directory. In that case, you do not provide the domain name in the URL. You provide the word organizations. You may have seen common instead. That's also possible. The word common also works, but common is more broader. That is also used for non-work accounts, also for personal accounts, but we don't support that. So you should go with organizations, and you will see in the demo that actually Microsoft is also doing that. The second part is the client ID. That client ID is assigned to that app during the app registration. You just create an app registration and you get a client ID. The third part is the code, response type. I expect to get back a code, an authorization code, that can later be redeemed for an access token. This redirect URI is the place where you want the authorization code to be returned. Now, this URI needs to be a web page that your application owns, because otherwise he does not have access to that page and the authorization code would be sent to a different application. So it is very important that you have access to that redirect URI, or if you have an application, like a desktop application that opens up its own browser window, of course it can be any URL in that case, because the application can just see if that browser window is navigating to another URL and then say, okay, thank you, I grabbed that URL. On that URL, I will find the code and I'm done. But that is for desktop applications only. For web applications working in a browser, this URL must be a URL that is hosted by the same application, otherwise you do not have access. This property just says that the authorization code needs to be added to that URL from number 4 in a query parameter, meaning it's going to be $code is. And this one is the scope, the permission that we request. This permission, in this case, user impersonation on that resource. Well, this is opened in a browser window somehow. The user is logging in. Azure Active Directory says, hey, do you want to grant access first time to that application? He knows the name because the client ID is here knows the name of that application. Do you grant him access to this resource? And you say, yes, that's okay. And then Azure is going to send the user back in that browser window to this redirect URI. And it looks like this. In the browser window, or in that application window, there is a redirect to this URL with a question mark code equals and then a very long code and a session state. So the redirect URI from step 1, an authorization code that is important for that application because that needs to be used in step number 3. That authorization code will be valid for 10 minutes. So in 10 minutes he must take step 3, otherwise that code is expired. And there is a session state which cannot be used for single sign-in, but for single sign-out. We're usually ignoring that one. That's for web applications who wants to log out a user everywhere. They can use that session state, log out, and that is kind of a cookie that you can store somehow. Then we get step number 3. The application retrieve that code from that URL, from that redirect URI. And then it's going to make an HTTP post request to the token endpoint. So a post request to the token endpoint of Azure. It is exactly the same URL as in step 1, but only the last word is different. So here, oops, I need to go a lot of click here. Here you see the authorized endpoint, and this part is exactly the same as in step number 3, but now it is called token. That is not a user interactive thing, it's a real API. He's going to post some data, which is always in the format, in the content type, form URL encoded. This just tells him that this body is in this format. The grant type that I want to use is authorization code. You will see when we talk about client credentials that he's going to call this the very same URL, but then grant type is suddenly client credentials and not authorization code. On number 4, we see the code that we retrieved in the previous step on that redirect URI. Then we provide also the credentials of the application. What is the client ID? What is the redirect URI that was used in the previous step? So where did you get that authorization code from? Because one application could potentially have more than one redirect URI, and you need to use the same redirect URI here is where you got that authorization code from. Do not pick one of the others, because then Azure will say, sorry, but this code does not match that redirect URI. The scope must be repeated here, and then we get the client secret. The client secret that identifies the client. There is more to that secret. I will come to that in detail later. But the client secret is in fact used as a password. In the Azure portal, you will see the word secret. If you look into the Graph API, it is not called secret, it is called password. And when you click on Add New Secret, Azure Portal is calling the API Add Password. Just saying. Now I have a question for you, just to think about it. I will come to give an answer later, but the question is this. If basic authentication is not secure, that's what Microsoft says, right? Basic authentication is not secure. Why is it not secure? Because the password is in the request. Basic authentication passes in a username and a password inside the request in the header, base64 encoded. So that's not so secure because the password travels over the internet, over the network. Okay, fair enough. But what happens here? There is a password, a secret in this call. Okay, it's not in the header. It's in the body. But that makes no difference in terms of security. There is still a secret, a password. We call it a secret, but it's in fact a password. Still traveling over the internet. If somebody would be able to unencrypt this, they have their hands on the secret. How secure is that compared to basic authentication? Does that really add a lot of security? I will come to that later. Just think about it. Okay, it is demo time. What I'm going to do is switching to Azure Portal, creating an app registration, making some calls to get all of this, what you just have seen. So, let me switch to the demo. Okay. Demo gods, thank you. It was a joke. Just to see if you're all awake. Okay. This morning I saw a tweet that's saying, pro tip, add randomly somewhere in your presentation a blue screen of death, forget where it was, because the adrenaline will keep you sharp. Okay. What would be really prank is if you have a co-presenter and you don't tell him that you put it in there. I tried to convince other presenters, but they didn't want it. Okay, so I'm here in an admin user, and I'm going to the Azure portal. And in the Azure portal, I go to the Azure Active Directory. And in there, I go to App Registrations. And I'm going to create a new app registration. And I'm going to call that the BC TechDays 22 demo. Now we see already here the first thing that we need to decide on, who can use this application. This organizational directory, Kronos company only. So by the way, the Kronos.company is really what we are in here. So I own that domain. Do you want to have any organizational directory which is multi-tenant? Or is it going to be accounts plus personal Microsoft accounts or only personal Microsoft accounts? Now the last two options should be ignored. We're not working with personal accounts like Skype, Xbox, Outlook.com, Hotmail, and all these kind of accounts. So only talking about the first two options. And in this case, I'm going to use a single account, a single tenant only. And I have a reason for that, because a multi-tenant is a little bit more secure and can only be used if I have a verified publisher. But that means that I need to register my Kronos company name with Microsoft as a verified publisher, and you want to see a document that it is really an existing company, and it doesn't exist. This is demo. So I'm not going to do this. So I choose accounts, organizational directory only, single tenant, that will do for the demo. And I get here redirect URI, which I will now skip for this moment and go to register. So I have now registered my application. If I need to zoom in, by the way, just say the word. Can everybody read this? Perfect? Okay, thank you. Then I see here the application or client ID. Both are used. Application ID or client ID, both terms are used everywhere, and well, they just mean the same. Sometimes you see client ID, sometimes you see application ID. You also see here object ID. Object ID, you should ignore that. Object ID is in fact the primary key of this record in the Azure Active Directory. Ignore it. we are talking about the application ID. That identifies him to everybody. So I copy that one because that is the one that I need to use in my requests. So I have prepared some of the requests here. This is my client ID. This, because I'm going to use a delegated flow, that means that I need to have a redirect URI. I need to have an interactive login, and the user needs to be redirected somewhere. So that is done. I skipped that in the first place, but now I have to do this. That is added under platform configurations. Now, here I have a couple of options, and I have also a slide about it, but 24 minutes left, so let me already explain what the difference is here. We have the option web. If the option is web, then I indicate to Azure that I'm working with a web application. Now, obviously, what is the characteristic of a web application? That it runs with a client in the browser, right? And in most cases, there is a back-end server that is then accessing the data, which means that I'm going to use the browser to let the user log in and let him redirect to a URI, to a URL that is hosted by the very same application in the browser. That means that that authorization code ends up in the browser and needs to travel from the browser to the server back. So the server can use it to get an access token. So there is an additional traveling of that authorization code to the server. At the same time, the server needs to use their code to get an access token. Now, if somebody could get that access token in between, then he would get the keys to the kingdom. Because he could just know, okay, this is this client ID and blah, 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 and I get a token. And to make sure that that attack, it's an official attack that is documented in the OAuth documentation, that that attack does not succeed, the web application on the server needs to have a secret to identify himself that is really the application that belongs to that login page. We call that, in other words, a confidential client. And a confidential client is a client that can keep a secret. Because it's on the server, users don't have access. So if I choose here web, that also implies that I need a secret in the final step. I skip single page application, Mac OS, Android, but this mobile and desktop applications is the other type that I want to point out. A desktop application is not confidential because a desktop application can never keep a secret. You see, even Teams from Microsoft cannot keep secrets. Don't be like Microsoft. Don't store any secret data somewhere on a desktop computer. There will be somebody who finds out where you put it. Registry, an encrypted file, whatever, they will find it. That means that a desktop application cannot use a secret. But a desktop application usually is capable of opening its own browser window. That means that everything stays inside that application. Okay, that's nice because then it's still safe. You do not need a secret in that case because that authorization code comes back into that application and never leaves it anymore, so it cannot be sniffed anyway. So I'm going to have a web application and a redirect URI. I'm going to use a very simple one just for the demo, localhost. The only URI that I can use without HTTPS. Otherwise, it must be HTTPS. So I configure that, and I see now here under web, one redirect URI. I can have multiple if I want to. Then I have a certificate and secret. And here I can create a new client secret that I need, the password. Expiration, it's all okay, 6 months. And here I have my secret value that I also need in my demo. There we go. You can all take pictures now and do the same, because now we have full access to my environment. So rest assured, I'm gonna recycle this after the demo, of course. Okay, so here you see the scope that I want to have access to. It looks maybe a little bit weird, but that is because it is URL encoded. What the full value is in readable, human readable characters is this one. Well, here I have my authorization code, the request. The full request that I actually need to send a user to in a browser window. That's what we are going to do. And just click on send request here. This is the output. Oh, this is not a browser window. Okay, so let me get the full URL. Here it is. This is my browser window that there's a user in the same Active Directory that is going to log in. So I click on that one, and there we go. Logging in, entering my password. There we have the permissions requested. This is already something that many people struggle with, but now you see how easy it is. Apparently, my user is an admin user, so he could click on consent on behalf of the organization. I'm not going to do that. But here you see the permissions. Full access to Business Central. Okay, full access. Does that mean that he is a super user? No. It just means that he can have access to Business Central with his user account, still restricted by the permissions assigned to the user account in Business Central. So I say accept. Now he is trying to open localhost. That does not work because nothing is waiting at localhost. So give him a few seconds to figure that out. The browser will come up with not found something. Yeah, come on, you can do it. Please, come on. Usually it doesn't take that long. Ah, there we go. Localhost. Could not find localhost. Let me copy that URL, paste it in Notepad, and here you see that he's opening localhost with a code which travels all the way up to here to session state. This is my authorization code. This is the value that I need to grab with an application from that URL. Whether it's a web application or a desktop application, this code needs to be read from that redirect URI. So I'm copying that, so I got it, everything is manual here, and I go back into my demo here, and I want to get an access token, and delete that code and paste a new one. This is exactly the same request that you saw on the slides. The client ID is here, the redirect URI, scope, secret is as variables. I sent that request, and here I have an access token. If I grab this access token, all the way to here, Control C, go to jwt.io, paste it in here, And here you see the details. Audience, that's the target resource, is identified with API Business Center on dynamics.com. I am this user, and I was asking for, let me see, user impersonation. This is my scope. So this should be a valid access token that will expire, by the way, in 60 minutes. So I still wonder why Teams is storing those access tokens, because they expire anyway. So you should keep them in memory. So this is my access token, is already stored here in this variable, and that means that I can now get, well, a company ID together with the authorization header, bearer, and that access token. Let us see. Let me make the request a little bit easier. There we go. This is my company ID. Control C, so let's add that one to the end of the URL. And then take customers, send the request, and there we go. We have a list of customers. So it just works. Okay, so this is the authorization code grant flow, and it depends on your application how you are getting the authorization code and how you are getting access, of how you are using that redirect URI. Okay, so let me resume. Come on. We should be much farther in the presentation. Where is it? Yeah, this is the place where we finished, right? Okay. That redirect URI, explained to you, is required for user interactive flows used by Azure to send back that authorization code back to the application, and there are some extra parameters added to it. Now you register the redirect URI under one of the platforms. And the platform type defines if a secret or a certificate is required in a final step. And that is confidential or public app. Web application is a confidential app. Could be a single page application, mobile, desktop, confidential app and a single page application, a mobile or a desktop application, they are public apps. They cannot keep a secret. Confidential app runs on a server. User has not direct access to it. And the authorization code, that is a characteristic of it, goes from the browser, from the client to the server in order to let the server exchange it for an access token. While the public application usually runs on a device or on a desktop and runs in a web browser, in an application window. Of course, there could be an interaction with a browser. That's a little bit more technical how that works, but at least the authorization code could not be sniffed. That is the characteristic of a public application. Then we have something that is called client credentials flow. That is the same post as we saw earlier on the token endpoint, but now it is a only one request that we need to make. In that URL, we must provide the domain name. That is mandatory. We cannot use common or organization because we are logging in as one application inside a specific Azure Active Directory. Content type, same thing. The grant type is now client credentials and not authorization code. We provide the client ID and the secret and the scope, and that's it. And we will be greeted with a access token. Now, let me do a quick demo of this. I see I have 10 minutes left, so I need to speed up a little bit. So how does that work? Here I'm back in my app registration. What I need for client credentials is an API permission here. Hey, I did not touch this before, but I did get access with the delegated permission, didn't I? Well, that is because I used something that is called dynamic permissions. Request the permission the moment that you ask a user to log in. Anything we define here on the app registration level is called a static permission. That is, register the required permissions up front. That's static. It's in the definition of the app registration. For delegated permissions, that is actually not required. We can access them or ask them to the user the moment that we need it. We don't have to do it upfront. But for a client credentials flow, an application permission, it is required. So I click on Add a Permission, choose Business Central, choose Application Permission here, and then grab API read-write.all. I add that permission, and I have it here in my list, and I get an exclamation mark here saying, not granted. Well, I can do that here, grant admin consent. Oops, there we go. And now I have everything to get an access token. So I go back to this one here, grab client ID and a secret that I have already from the previous call, go to my client credentials flow here. There you go. And this is my request to the token endpoint. And here I have a access token. Let's go to jwt.io, paste it in here, and here I see a role API read-write.all. So now I can use this access token to call Business Central. Well, this is gonna fail, I can tell you already, because I will now get authentication invalid credentials rejected. And that is because in Business Central I need to register this user, this application user, otherwise he does not know him. And I'm using the demo account, so that's perfect. This is my client ID. Gonna quickly do that. I have only a few minutes left and I need to open up for Q&A, so I will speed up now. AID, create a new one. This is my client ID. And enable it. Okay. What is your problem? 2 errors. I need to... description is mandatory, probably, yes. Sorry. This is demo BC TechDays. Whatever. Yes. A new user has now been created in the user table. Only need to give him some access. Let's be easy here, super. Oh, that does not work. Super cannot be applied. Well, I know a small workaround for this, but for now I'm going to add another one, like full, give him full access. This you do it. Go back to this one here. Make the request again. Oh, that was the token. Send the request, and there we go. Now I have the data back from Business Central. So all of that works. final slides then. Yeah. So what I just did was creating the application account in Business Central that is linked to the application account from the app registration. Then the secret, I promise you to come back to that one. Secret is a password, proves the identity, has a lifetime of maximum 24 months. So it could be narrowed down to maybe 1 month or 6 months or whatever, so it's a little bit more secret if it leaks. You should never store it in code anywhere. And it's recommended for officially docs in only development or test scenarios. The better way to use is certificates. Because with certificates, it never leaves the application. You sign a request with a private key and it never travels over the internet. So certificates is actually the way to go. Luckily, the libraries in .NET, for example, fully support this. And we can also use it from AL code, the other way around, to the outside world. I'm writing some code actually right now to enable all of that. Static permissions versus dynamic, I've already explained that. Very quickly, if you want to use OAuth in C#, I recommend you to get a NuGet package, microsoft.identity.client, and you don't have to work with all those details, because you just create a client application, either public or confidential, in the code, with the client ID, with the secrets, and you grab it with the acquire token interactive or acquire token for client call, and that will make everything work. I have an example of that, but I have 3 minutes left and I need to open up for Q&A. So that demo, maybe another time. I hope at the end of this, you have seen at least the steps in between to draw an O, at least the pieces that put that one together. I hope so. Are there any questions? And I have something to throw to the person who has a question, so... A little bit too far.
That's a heavy one.
So I have a question about the multi-tenant.
Multi-tenant, yes.
If you have an app which is accessing more than one Business Central environment for more customers, would you rather say it's best practice to have one app registration or have more app registration for every customer? Because if the client secret is leaked, you would have access to all customers.
Yeah, very good question. So I would prefer to have multiple app registrations, preferably in the customer Azure Active Directory. The only moment that I would not do that is when I own the code on my own platform and nobody else has access to it. But as soon as there's a distributed application running on different sites, so on-premise, then definitely have multiple app registrations. Yes.
Okay, thank you.
Yep. You had a question. You need another one? Well, this one works. Okay, some exercise here.
Okay, for me it's a little review, you can say, because I don't quite understood the difference between the dynamic and the static permissions.
Yeah, so
in the end then.
Dynamic permissions are not registered in the app registration, so you do not select them in the Azure portal, but you request them together with that authorized endpoint. So when you send the user to the authorized endpoint, you add a scope in that request, and it is then a scope that is not part of the app registration.
Yep.
And at that moment, if the user say yes, it is dynamically added to the service principal. So it's not in the app registration and only on the service principal.
Yeah, that partly I understood, but where does the scope for this come? Because dynamic ones are not always the same requests for the customer, I think. So
So they're not always the same because one time you need scope A and the second time you need scope B. So the moment you ask the user to authorize, you tell them which scope you need at that moment.
Okay, so it's more like the user decided what scope he want to enter.
To narrow down the access token that you get. Because if you get an access token for all the permissions that you have been granted, that access token would give you too much access for the purpose that you may need at that moment.
Okay, I think I'm now a little bit better.
Okay, good. I see somebody there.
Thank you. So let's say we have multiple applications that require basically the same permissions to access the objects in Business Central. Is it better to create to register each app individually, or can we just reuse one app registration? So let's say we have 5 Azure functions that are all basically require the same permissions.
You can reuse it in that case.
Okay.
Yeah, I would say so. Yeah.
Thank you.
Any further questions? Come on. Please pass it on.
So did you say you had a working example with certificates instead of client secrets that
Yes.
you were willing to share in the future?
Of course, I'm going to do that. So that example that I created is this. In AL code, I know there is a wizard, for example, that Microsoft has a small wizard which says, okay, please enter here your app ID, your client ID, and your secret.
Yes.
Yeah? And then there's a link to docs that say, okay, you need to create an app registration, you need to add these and these permissions, you need to do this and this and this, and then you get an app ID and a secret, you enter it here. I have 2 problems with that approach. First of all, it requires the end user to do that, and it works with a secret. So what I have created in the first place is an application, an AL app, that does not ask the user for a client ID. It creates the client, the app registration in the Graph API. So the only thing he asks to the user is, please give me access to your Azure Active Directory. I do it for you. I create the app registration, I can create a secret, or I can create a certificate as a self-signed certificate, all in AL code. And I'm going to use that certificate to make the calls. And all of that in AL code without any external module. It's all there. You just have to put the pieces together. So I've done that and it works. I just need to write a blog post and finish it and blah, blah, blah. So it's going to take a couple of weeks, but it will be there.
Hallelujah.
Okay. Be careful with that thingy.
I just want to ask, token expiry is 24 hours normally, right?
Yes, token
So-
expires in about 60 minutes. Could be a little bit less, a little bit more. You never know exactly, but it's about
Yeah.
60 minutes.
60 or 24 hours?
12?
24 hours or 60?
No. 60 minutes, or sometimes it's 70 minutes or 75,
Okay.
but something in between.
Okay, let's say it's 60 minutes, yeah?
Yeah.
So between the applications, we have like multiple calls,
Yeah.
right? So every time when we request one, let's say every time we have one call, we have to request one token, basically.
Yeah.
So
So-
there's a limit for the tokens, which is actually costly, you know, if you have the multiple thing. And do you recommend that token buffering for 60 minutes?
So Azure does not care if you request multiple access tokens in a short time. They would rather have you make multiple calls instead of storing the token somewhere that it can leak. But the token is valid for 60 minutes. So that means that you can keep the token in memory for 60 minutes, and after 60 minutes say, okay, sorry, now the token doesn't work anymore, so I need to have a new one. Getting the new token can be in two ways. Number one, you just pop up a new window saying, please log in, and do the whole exercise again. The user will probably not even notice it. And if you're doing it in the right way, it can even be without any pop-up. Microsoft decided to go with the pop-up anyway, but in Business Central. You can also use the refresh token. And the refresh token is something you can retrieve with the access token together and use that in the background to get a new access token. And that will give you access as long as you want, because the refresh token can even give you access tomorrow or next week. The refresh token, I didn't touch it yet, because I need to make some decisions because of the time, but the refresh token is valid for 90 days. And if you use the refresh token to get a new access token, you also get another refresh token valid for another 90 days. So as long as you stay in those 90 days, you will be fine. Except for those Azure tenants where they have configured that the user needs to be interactively logged in every 2 weeks, for example. In that case, because that is a configuration that can be done, and some people do that, then the refresh token is not going to work, because the refresh token is trying to log in a user without interactive login. And then Azure says, sorry, this user has not logged in for 2 weeks, so I'm not going to do it for you. Well, good luck with working with an access and a refresh token in the background process that you retrieve from a user. And that user is going on vacation for 3 weeks. So after 2 weeks, the background process is not going to work anymore. I've seen those situations. So it's a lot more than just a refresh token. You need really to know how Azure is configured.
Mm-hmm. I mean, my difficulty is, I'm facing this in a practical life, day-to-day life, because I'm not really sure that whether we should save it in a table field or something as a buffer. I mean, we don't use the refresh token. We just use the 60 minutes tokens.
Yeah.
So just wanted to see if there's any other way that we can secure it place, because it's not secured, like if we save it in a setup table buffer or something like that, right?
There are definitely other ways as well. Definitely, yeah.
Okay.
So I see people leaving. Thank you for being here and watching this. I hope it was useful. And there are some T-shirts that you just shall I throw them? Yes. Okay. I don't know. Oh, there's another one. Sorry for you guys in the back.